the Green Revolution, India achieved self-sufficiency in food grain production. However, 78% of pregnant women are anemic and 53% children suffer from malnutrition. Vegetables play an important role in providing nutritional security as they are a good source of minerals, vitamins and fiber. Today, India is the second largest producer of vegetables in the world, currently producing 90 million metric tons of vegetables grown in an area of 6 million hectares across the country. Yet, a significant part of the produce is destroyed and wasted because of the incidence of pests and diseases. Hence, our productivity is far below world standards. Majority of the farmers in India are poor and lack the know-how on the scientific use of plant protection. More often, they use ineffective and non-target chemicals, spray indiscriminately, and also use a cocktail of pesticides. Many insects have in fact developed high level of resistance to insecticides. From a mere few in the 1960s, today nearly 500 insects have developed high level of resistance to insecticides. Indiscriminate use of insecticides has resulted in the outbreak of secondary pests like aphids, red spider mites, and whitefly. A number of natural enemies and pollinators have almost been eliminated in the cropping system. These harmful chemicals affect soil, water, food chain, environment, and cause irreparable damage for many generations to come. The harmful pesticide residues in vegetables pose a serious health hazard to human beings, especially in cabbage, tomato, cucumber, which are consumed fresh as salad or sandwich or raita. The use of pesticides can be greatly minimized, if not totally eliminated altogether. This will also ensure vegetable production that is economically and ecologically sound, but at the same time ensuring nutritional security and sustainability. Considering all the undesirable effects of pesticides, integrated pest management, popularly known as IPM, was proposed in the 1970s. IPM is the rational combination of different methods of pest control like cultural methods, mechanical methods, use of botanicals, biological control agents, and timely and minimal use of selective chemicals. The Indian Institute of Horticultural Research at Bangalore, popularly known as IIHR, is one of the premier institutes working on IPM of vegetables in our country and the Asian continent.
The integrated pest management in vegetables is the rational combination of two or more methods of management, which is more sustainable, long lasting, and also without much use of the chemical pesticides. So, this way you can produce the pesticide residue free vegetables for consumption by the consumers.
The entomology and nematology division of this institute has developed a multitude of eco-friendly methods in pest control in cabbage, tomato, brinjal and other vegetables.
Among the vegetables, chiefly cabbage, cauliflower, tomato, brinjal are the chief vegetable crops, and they consume on an average 15% of pesticides that is used in our country.
Cabbage IPM. The main pest of cabbage is the diamond-back moth. This is the most serious pest of cabbage and cauliflower throughout the world. Other main pests of cabbage are leaf webber, stem borer and aphids. Farmers spray 15 to 16 rounds of insecticides on a single cabbage crop, especially during summer. In spite of this, the pest may not be effectively controlled. IPM for cabbage begins in the nursery itself. Spray cabbage nursery with Bacillus thuringiensis, popularly referred to as BT, to prevent early diamond-back moth incidents. Use mustard as a trap crop to attract all the pests of cabbage. For every 25 rows of cabbage, 1 row of mustard is sown as a trap crop. Thick sowing of mustard ensures enough foliage to trap large number of insects. The mustard trap crop attracts diamondback moth, aphids, leaf webber, stem borer and mustard sawfly. The foliage of mustard has to be protected by selective sprays of dichlorvos, a non-persistent pesticide. However, in cabbage IPM, use of mustard as a trap crop alone is not enough. Extensive research carried by vegetable entomologists at IIHR has indicated that in crucifers, the primordial stage is the most critical stage of crop growth. Hence, application of neem seed extract 4% or soap formulations at primordial initiation is critical. For the sprays of neem to be effective in pest control, select good quality seeds during August month when plenty of seeds are available in the market, and powder through pulverizer. Powdering through pulverizer retains all the essential active ingredients of neem seeds. Soak 800 grams of pulverized neem seed powder in 2 liters of water for 12 hours or overnight. Filter through double-layered nylon net repeatedly. And make up the volume to 20 liters and spray. 1 hectare of the cabbage crop requires about 40 kg of pulverized neem seed powder. In many parts of our country, neem seed is not always available. To overcome this bottleneck, research carried out at IIHR has shown that soap formulation of neem or pungamia can be used effectively for pest control. These soaps are prepared from the respective oils available throughout the country. The soaps are in the form of pastes. Both the soaps are equally effective on all the pests of cabbage. Dissolve 200 grams of neem or pungamia soap in 20 liters of water and spray. 1 hectare of cabbage requires 6 to 8 kg of soap. To get effective control, spray the crop thoroughly. Like neem seed extract, soap formulations also have to be given to cabbage at primordial stage and repeated 2 to 3 times at 10 to 15 days interval for effective pest management. Spraying of neem seed extract or soap formulations are effective even in the absence of trap crop. Sometimes Spodoptera, a caterpillar pest, may appear on the cabbage crop. The young gregarious larvae have to be located and mechanically destroyed.
In spite of several rounds of chemical sprays, the farmers are not in a position to control the cabbage pests very effectively. In view of this, the Indian Institute of Horticultural Research has developed an integrated pest management technology. The farmers are in a position to produce pesticide-free cabbages.
Even hybrid cabbage can be successfully raised without a single spray of synthetic insecticide all through the year, using only botanicals, biopesticides, trap crop and selective cultural mechanical practices. However, following steps are involved in cabbage IPM. Spray BT in nursery at 10 days after sowing and 1 day before planting. Sow 1 row of mustard for every 25 rows of cabbage. Spray mustard with dichlorvos 2 to 3 times to protect foliage. Spray cabbage with neem or pungamia soaps or neem extract 20 days after planting and repeat 2 to 3 times. A healthy crop is obtained without single synthetic insecticide application. Like cabbage, tomato is one of the most important vegetables grown all over the world. In tomato, fruit borer is the major pest. This pest causes crop loss up to 40%. Serpentine leaf miner is another major insect pest of tomato and number of other vegetables. These two pests have developed resistance to many insecticides and are very difficult to control using synthetic pesticides. Many insects, though not directly considered as pests, act as vectors in transmitting diseases. Tomato leaf curl, an important viral disease, is transmitted by white fly. In tomato IPM, nursery of marigold variety, the golden age is raised 15 days earlier than tomato nursery. During summer months, leaf curl tolerant F1 hybrids available in the market have to be grown. In addition, raising virus-free seedlings inside nylon mesh reduces the leaf curl incidence in the main field. Before planting tomato, dip the roots of seedlings in a systemic insecticide solution to reduce vector transmission. Plant 45-day-old marigold and 30-day-old tomato seedlings simultaneously. Plant 1 row of marigold for every 16 rows of tomato. This is done to synchronize flowering in both the crops. If leaf miner incidence is observed on young plants, spray 4% neem seed powder extract. Remove leaf curl affected plants and follow clean cultivation to reduce viral diseases in main field. When tomato flowers, the fruit borer moth lays eggs on the trifoliate leaf immediately below the topmost flower cluster. However, when marigold trap crop flowers along with tomato, the moth gets attracted to marigold and eggs are laid on its flower buds and flowers. Thus, the fruit borer incidence in tomato gets reduced. Pest monitoring is another important component of IPM. To monitor the tomato fruit borer on tomato, 6 pheromone traps can be erected. Adult moths of the borer caught in the traps indicate the activity of the borer. In addition, tomato crop has to be sprayed with nuclear polyhedrosis virus at 28, 35 and 42 days after planting. This virus is very specific to the borer and harmless to all other insects. Jaggery is used here as sunscreen to delay the degradation of the virus from sunlight. For this purpose, 1% jaggery has to be mixed and sprayed along with NPV in the evening. Where NPV is not available, 2 sprays of endosulfan at 28 and 35 days after planting has to be given to control fruit borer. Use of protective gear is essential while spraying hazardous pesticides. This IPM reduces leaf miner, fruit borer and leaf curl to the minimum. Quality NPV and pheromone traps have to be used to ensure success of this IPM. Steps involved in tomato IPM. Raise early marigold nursery. Raise tomato seedlings in nylon net. Dip the tomato roots in systemic insecticide before planting. Plant 45-day-old marigold and 30-day-old tomato seedlings. Plant 1 row of marigold for 16 rows of tomato. Spray neem seed extract 15 days after planting. Erect pheromone trap at flowering to monitor fruit borer moth. Spray nuclear polyhedrosis virus or endosulfan. In the absence of trap crop, spray nuclear polyhedrosis virus 4 times at 25, 29, 34 and 39 days after planting. Destroy leaf curl affected plants. IIHR has also developed IPM for other vegetables. The main pests of brinjal are brinjal shoot and fruit borer, hopper, midge, whitefly and mites. Of these, brinjal shoot and fruit borer has developed resistance to most of the insecticides in India and many South Asian countries. The borer initially attacks brinjal shoots and later, after flowering, attacks fruits. The damaged shoots and fruits along with the borers have to be destroyed. At present, effective natural enemies and resistant cultivars are not available against this pest. However, botanicals are moderately effective and economical. Neem cake has to be applied at the time of flowering and repeated twice at 30 to 45 days intervals. Cake application also reduces ash weevil grubs. These grubs feed on the roots and cause mortality of plants. Pungamia or Karanj cake is moderately effective in reducing brinjal borer. However, efficacy of cakes depend on their quality and prevailing weather conditions. The adults of shoot and fruit borer can be monitored by pheromone traps. Based on the trap catches, spraying of neem extract may be given. Neem, either as cake or neem seed powder extract, is moderately effective on leaf hopper, midge and many other insect pests. Indiscriminate use of synthetic pyrethroids and other insecticides cause resurgence of mites and whiteflies. Therefore, judicious application of botanicals like Pungamia oil or soap and a suitable alkalicide will avoid resurgence of mites and whiteflies. Neem seed extract is effective on serpentine leaf miner and fruit flies infesting cucurbits. Neem seed extract has to be given at flowering and repeated at 15 days interval to reduce fruit flies on cucurbits. Neem and Pungamia cakes also reduce okra fruit borer. Apply the cakes at 10 days after planting and repeat at 30 to 45 days interval to effectively reduce fruit borer incidence. Application of neem or Pungamia cake also reduces root knot nematodes in vegetables. The nematodes induce galls in roots and reduce crop growth and yield. The findings of the Institute are not merely laboratory experiments but have been successfully transferred to the actual field, empowering several farmers across the country. The transfer of technology is done through training. Exhibitions, publications, method and field demonstrations. Training programs are being organized for the field level extension personnel of state development departments and trainers of Krishi Vigyan Kendras across the country.
As a feedback received from these ex-trainees, we understand that all this technology on IPM in cabbage and IPM tomato has been transferred successfully to the various regions all over the country, especially where cabbage and tomato is grown.
These IPM technologies have been successfully transferred through village adoption program, wherein 5 villages were adopted and IPM technologies were apprised and also shown through demonstrations.
We have adopted 5 villages near Bangalore and we have demonstrated these IPMs in about 15 hectare area, and farmers have got very good profit because they have used minimum pesticides.
The adopted farmers have enjoyed the benefits of IPM technology that have heralded a scientific method of pest management.
We have done as suggested by the Indian Horticultural Institute. Earlier, we spent more. First 3 times, all the insecticides were supplied by them. They also gave us information, visited and inspected our lands 2 to 3 times. With this, the expenditure was reduced and the profit is now more. Earlier, we sprayed pesticides 10 to 15 times. Because of this, crops were not good, loss increased. In the training, they told us they will give us neem oil and neem. We sprayed 4 times. Pests are now under control and the crops are good. Before sowing, we sprayed the neem oil. Again at the time of preparing the rows and later during the flowering time. We have sprayed 3 times. Pests have reduced and now even 5% of the pests are not seen.
Thus, IPM in vegetables plays a vital role in ensuring nutritional security. Through the use of trap crops, neem seed extract, neem cake, soap formulations, pheromones, NPV, BT, and a combination of various approaches, IPM drastically reduces the load of pesticides on vegetables. The pesticide-free products will further ensure the survival and conservation of natural enemies and the ecosystem. Therefore, IPM will contribute towards the successful cultivation of vegetables that are ecologically and economically viable, a process that will benefit both the farmers, the consumer, and above all, Mother Nature.